What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at part 9 of our tutorial series, Scientific and Numeric Computing in Python. I should mention to you, if you have been following along in the series so far, you will know that so far, guys, we have discussed the NumPy package in Python. Okay, numerical Python, we have explored quite a bit of interesting features and functions that are offered to us by this package. Now, this video, part 9, is the last video in the series that talks and teaches us about the NumPy package. Okay, from video 10 onwards, we will be exploring the SciPy package in Python. Now, I should mention that this last video regarding NumPy, what we will be doing is just nothing too strenuous. Essentially, we will be exploring more features offered by NumPy, and these features are kind of, I would say, easy to understand because we will be looking at some just general basic mathematic operations that can be performed, on NumPy arrays. Now, let's get to it. So I'd like to just kickstart this lesson talking a bit about math. So math, mathematics. Okay. Now, Python, as you know, right? We've mentioned this before. NumPy is a package. It's a library. It's a dependency. Okay. Now, Python has several packages that actually help us out, with performing mathematics, any related mathematic operation. We can perform it in Python, and we are not limited to using NumPy. Okay, I mean, I'm sure you guys are familiar that Python has what's called the math module, math. This is built into Python, and it offers us various mathematic functions and features that we can use. Okay, now the thing is, you have a variety of options to actually go about, doing your mathematic operations. Now, the preference is all up to you. Whichever package you like to use, you can use. Now, specifically, NumPy kind of makes an entrance when we are computing on large, I would say, problems. Okay, when equations are large and we just have certain, array transformations to do, then that's when NumPy will come into play. So let's get to it. Now, you see, the first thing I'd like to talk about within the math discussion, and I'd like to demonstrate for you guys, is linear algebra. Linear algebra is something that's very, very interesting. Okay, we all learn this when we are in high school. Essentially, you guys know in maths we have these equations in which we have to solve for the unknown variable. Okay, and basically now I will demonstrate for you how NumPy comes into play in this specific kind of context, in the context of linear algebra. It is interesting. Now, you guys know, right? NumPy supports broadcasting. Broadcasting essentially means that looping operations are no longer needed for actually traversing or, iterating through that array. Now, I'd like to reinforce this, that guys, you have a choice. Okay, you can use any package and any NumPy method that you like in order to go about solving, your equations and just your mathematics related problems. So I'd like to just bring your attention to two important facts that are a part of a NumPy of the NumPy array. You guys know we've been using np.array all along. Now, what's interesting is that there's also this method called numpy.matrix, and I should mention to you that, I mean, logically speaking, right, there is not much difference between the NumPy array and the NumPy matrix methods, because essentially we are working with an ND array irrespective of which one we choose. But a NumPy array can create for us a 1D array, whereas the numpy.matrix will create for us a 2D or more D array, because essentially these are two vocabularies you should be familiar with in your journey with Python. These vocabularies are vector and matrix. Okay, a vector is a 1D array and a matrix is a 2D or more array. So essentially, NumPy.array allows the creation of vectors and matrices, but you see, NumPy.matrix will only create for us a matrix. So that's that. I can give you a little demonstration. So import, oh, we actually imported. Let's do NumPy.array. And you guys know we have been doing this all along. That's a 1D array, and I can transform this into a 2D array. So 4, 5, 6, and here we have a 2D array, and this is being created using the numpy.array method. So let's explore a quick example of np.matrix. Again, if you guys would like to check the documentation, all you need to do in Spider is the name of the method of function and a question mark afterwards, and as you guys will see, it always returns a matrix. That's the keyword, okay? A 2D or more D array. So let's just create a simple one. Let's do 2, and as you guys can see, I created, or I passed in the value with a single square bracket, but given the fact that we are working with a numpy.matrix method, it has automatically converted my values, my input, into a matrix, which is having 2 dimensions, because a standard matrix or your typical matrix will have 2 dimensions. So I hope that is interesting to you. Now, coming back to our important discussion, what I'm about to show you, you will have the ability to do it using NumPy matrix or NumPy.array. The choice is yours, but from the logical perspective, there is no difference or there's no influence on the calculation or the outcome of your calculation. Everything is the same. It all stems down to your preference of method choice. So you may ask now, right, what are we about to do? So you guys know, right, in the subject or field of mathematics, we have these equations, and these equations we have to solve for the unknown variables. Okay, now this is a part of linear algebra. So suppose we have 3 equations. We have 3x plus 6y minus 5z equals 12. And here we have another equation. Suppose we have x minus 3y plus 2z is equals to, let's say, minus 2. Then we have 5x minus y plus 4z is equals to 10. Okay, those are the 3 equations we have. Now, logically speaking, what I want you to do is picture these equations in array representation, because in NumPy, right, everything can be represented, well, numbers rather, can be represented in array format. So just to give you a bit of perspective, right, I want you to intuitively and logically picture these equations as matrices of NumPy arrays basically. So I will give you the visual now on the screen. So we have arrays. This is going to be one large array. So basically I have within the first array, I have the values. So this will be a 2D array. I have the values 3, I have the value 6 and negative 5. Think about it, guys. All we are doing is extracting the numbers, because this can basically be separated into 3 portions. Every equation can be separated into 3 portions: the constants, the variables, and the final answer, or the number on the right. So this is what we are doing, right? We are separating now, and we are creating our NumPy matrices. This is just for you to visualize so that you get a better understanding. Okay, so 3, 6, negative 5. Now I have another one here. I have 1, minus 3, and plus 2. So that's just 2. And then we have 5, minus 1, and 4. Okay, guys? So the array that we have created here, this matrix, really it consists of basically each equation, the left-hand side of each equation. Okay, the constants. So the first one was 3x plus 6y minus 5. And as you can see in the first array, I have 3, 6, and minus 5. So there's the 3. The 6 is coming from here, and the minus 5 is coming from here. In the second array, I have, or in the second element rather, I have 1, minus 3, and 2. So that's coming from here, the 1, the minus 3, and the positive 2. And the third follows the same logic. Now, the next important thing is the variable. So think about it logically, right, guys? We have these 3 variables, okay? And the thing is, we just choose, it's the way of maths. We just choose to give these variables different names. So X, Y, and Z. Logically speaking, you can call this J, K, L, A, B, C, anything you like, okay? You can even call all of them the same name. So you can say 3x plus 6x minus 5x. It is the same, logically speaking, okay? Because at the end of the day, they are all variables. So what we do is we just choose one variable name. Essentially, we have in the first, let's just say we have x. In the second, let's just say we are solving for y. And in the third, let's say we are solving for z. Okay, because logically speaking, let's take this first equation as an example. This here, I've isolated it. This could have been written as 3x plus 6x minus 5x is equals to 12. Okay, and essentially we would just be solving for x, and the result would be the same. Okay, so that is important. It still equates to 12. So coming back to what we were doing, all we have done is just given a single variable for each equation. And now the answer portion was basically, let's say we have 12. This should be up. 12, we have negative 2, and we have 10. Okay, now think about this, right? Because essentially what we are doing is we are taking, so I have the ability, now I can call these arrays that I have, I can say this array here, in the one in which the constants are stored, I can call that A. I can call the one storing the variables, I can call that, well, that's what we are solving for, but the one storing the results, I can call that B. So B, and here, I mean, since we are dealing with variables, I would like to just call this X. So take a moment to look at this, guys, and what you will realize is that when it comes to solving linear algebra using NumPy, we can work with a standardized formula. The matrix, the entire matrix system, basically the way in which we can go about solving for the unknown variable in an equation using NumPy matrices, it can be represented as the follows. So we have Ax is equals to B. And think about it, guys. Now what we are doing is we are trying to solve for x. Okay, so using some basic math rules, making x the subject of the formula, x would be equals to a to the power negative 1 multiplied by the b, which is basically, think of these as the variables in our equation. So x is equals to a to the power -1 multiplied by b. So taking this logic that we've just looked at, guys, I want us now to apply it to NumPy. So I will create another cell here, or instead I can just comment this. Okay, so I think I will use normal comments because, yeah, it would make it much more readable. Okay, guys, so that's what we have there. I hope you guys are finding this discussion, interesting. And now we will head on to hands-on solve for these equations. So first things first, right? I import my package, import NumPy as np. I will then proceed to define the matrices that form part of the equation. So we have already done it up here. All I need to do is convert that into the appropriate NumPy syntax. So I will do a is equals to NumPy dot matrix. So I will use the matrix method or function, given the fact that we are going to be working with matrices. So what I will do is the first square bracket to denote the array itself, and I can place my elements within the second level of square bracket. So 3, 6 and -5. Then I have 1, -3 and 2. I have 5, -1 and 4. That is the first array, which is A. Now, the next one we have is B. B only contains those 3 elements as well. So, B is equals to numpy.matrix. And now, the first level of square brackets for the array itself. Second level for the elements. So, 12, I have -2, and I have 10. So, that is B array. Now what I do is x is equals to, I am solving now. So using this formula here, I do a to the power -1. Let me enclose this in brackets. We want the math to be done correctly, multiplied by b. So now print x. And I should get values for each of these equations in an array. I am expecting the array x to contain 3 values, and those values will be basically the value of the variable that will solve this equation for us. Okay, so I hit Control Enter, and as you guys can see, I have 1.75, 1.75 and 0.75. Okay guys, so now that we have the matrix of x, essentially what we can do to make sure that these values are correct for our equations, what we can do is, since we have a and since we have x, I can multiply a by x as arrays to see if it gives me the result of b. Okay, and b, we already know what it is. It is 12, -2 and 10. So now in my IPython console, I will do a multiplied by x. Remember guys, a is what we have defined here. X is what we have just solved for. B was the answers we are expecting. So if I multiply a by x, and if the result of a by x is the answer of b, then I know that the equations have been correctly solved. So I will hit enter now. And as you guys can see, I have 12, -2 and 10. And this is what we were expecting. So that is interesting stuff. Now, that concludes the most important part of this tutorial that I wanted to, demonstrate to you. Essentially now what I would like to do is just a few, I would say, relaxed functions just to introduce you to that. So let's do another importation. Import NumPy as np. I would like to introduce you to the NumPy add function. So as explained by the name itself, the add function will allow us to add two or more arrays together. I think it is used to add two though. So let's double check this. So np.add. Yeah, so guys, two arrays. So what's important here that you need to know for the numpy.add function, I think the most important thing is that both arrays need to have the same number of elements in it. Okay, so essentially you cannot have an array that has maybe 5 elements and add it to an array that has only 3 elements. Okay, so both need to have the same number of elements. I will give you a small example of that. So numpy.array, suppose we have this array of 10, 20, 100, 200 and 500, and we have another array, maybe array b, numpy.array, and here we have suppose 3, 4, 5, 6 and 7. And now I want to do print numpy.add a with b. Now essentially it all stems back down to the concept we spoke about multiple times called broadcasting. Essentially what's going to happen here is each respective element in the first array will be added to the respective element in the second array. So 10 will be added to 3, 20 to 4, 100 to 5, 200 to 6 and 500 to 7. So let's print this out, and as you guys can see, 10 plus 3 is 13, 20 plus 4 is 24 and so on. So that is the add function for you. Now what I can do is demonstrate for you the NumPy. This is subtract. SUB, yes, I spelled that right. Function. So it's nothing too difficult, guys. It's, I would say, as you guys know, the name of the function is subtract. So we just change np.add to np.subtract. And what you will realize is I've copied and pasted the array we worked with earlier. Just to save time, I don't want this video to be excessively long because I'm sure you guys are ready to wrap up this NumPy tutorial. So I do numpy.subtract, and as you guys can see, 10 minus 3 gives me 7, 20 minus 4 gives me 16 and so on. And what's interesting that I should mention to you for you to just know that it is possible is that so A looks like that, B looks like that. Now what we just did was use numpy.add and numpy.subtract. I have the ability though to do A plus B. I have the ability to do A minus B. And yeah, so as you guys know, this is the standard, mathematical operators or arithmetic operators that Python supports. And because of the fact that NumPy arrays support broadcasting, we have the ability to actually utilize these operators directly on arrays. So all of that is possible. So that was the modulus which I just did there. So let's move on. I would like to now demonstrate to you the NumPy multiply function. So what I will do is I will create new arrays now. So numpy.array. Suppose we have 7, 3, 4, 5 and 1, and here we have array B, which is numpy.array, and within this array we have the values 3, 4, 5, 6, 7. So I did create these ones so we work with smaller numbers. It would be kind of large to multiply 500 by 7. So print numpy.multiply. We pass in two NumPy arrays A and B, and essentially 7 will be multiplied by 3, 3 by 4, 4 by 5 and so on, as you can see. The next interesting one we have is, and also guys, don't forget, you can use, the standard arithmetic operators in Python. All of them will work. Okay, so the next one I'd like to demonstrate to you is NumPy divide function. So for this, I'd like to just copy, the arrays we worked with earlier, and I can do print numpy.divide, and I pass in A and B. Now, when I run this, okay, that should have been a dot. Yeah, so when I run this, essentially what happens is 7 divides by 3 to give us that answer, 3 by 4 to give us 0.75, 4 by 5 to give us 0.8, and so on. It's all broadcasting, so element by element. This is actually why we require the two arrays that are being passed as arguments to the function to have the exact same number of elements. So that's that. Now, another thing I'd like to show you is the NumPy mod function, NumPy remainder function. So the NumPy mod function and the NumPy remainder. So both functions will output the remainder of the division operation. Okay, you guys know modulus is something we encounter in our early journey with Python. Okay, modulus will perform division and the answer will be the remainder. And remainder function is also one that exists in NumPy, and it will give us the same output. Okay, so that's just something I wanted to inform you about. So let's have a demonstration. I will copy these arrays that we worked with earlier. Print np dot mod a and b, and here we have the modulus operation, and then we have print. So I'll comment this for now, numpy.remainder, and let's pass a and b, and as you guys can see, the output is the same because what they apply to the array is the same kind of maths. So that's that. Another interesting one we have is what's called, so let me create another cell. The NumPy power function. So this is basically, exponent. Let's have an example. I will copy the array we used earlier. Print numpy.power a b, and as you guys will notice, essentially what happens is 7 gets raised to the power of 3 to give us 343, 3 to the power 4 to give us 81, 4 to the power 5 to give us 1024, and so on. We can make sure it's correct by just typing 7 times 7 times 7, and it is 343. So that's that. Now, really guys, this video is 30 minutes, and this is the last thing I wanted to show you, the NumPy power function. We have done a good amount of work in Python about the NumPy package, and as you guys can see, we started off with 0 lines of code, and at the end we have a Python script containing plus minus 500 lines of code purely about NumPy. Okay, I will post this to my website, and you guys can get the code from there. And with that guys, thanks for watching, thanks for staying till the end of the video. Good luck with your work, and I'll see you in the next video. The next video will be about SciPy package. Thanks guys.